Hello everyone, welcome to the Python conference. The topic of this session is Journey to the Center of Django. I would like to introduce you to our speaker for the session, Agustín Scaramuzza. Agustín is a software developer from Buenos Aires, Argentina. Hello, Agustín. Are you ready for your
Hello.
presentation?
I'm ready, yeah.
Great, then start.
Okay. This is a pre-recorded talk, so I'm going to play the video now. Have fun. Okay. Hello, everyone. Hello, PyCon Sweden. If you had ever told me that I would be giving a talk for a conference in Sweden on the other side of the Atlantic Ocean, then I would have probably laughed at you, but here we are. So thank you for the opportunity. Thank you for coming. And this is Journey to the Center of Django. I started using Python about 6 or 7 years ago, along with Django. I have always, well, not always, but mostly worked with both Python and Django, obviously. And the relationship between the language and the framework is something that I would like to explore in this talk. I think that Django is the framework that it is in great part because of Python. Of course, there's a lot of great people behind the framework, but there's also a lot of great people and ideas behind the language, and Django very much successfully fits on those ideas in order to do what it does. So why is the talk called Journey to the Center of Django? You've probably heard of a book called A Journey to the Center of the Earth, or even the movie based on that book. A book by Jules Verne. The main idea of the book, not to spoil anything, is a bunch of people going to a volcano. They find a lot of strange and crazy stuff in there, and then they get out. And Django is a huge framework. It has a lot of very nice features, and it can sometimes feel like a huge volcano filled with crazy stuff. And I hope by the end of this talk, we will be able to understand why some things are that way in Django. Not all of them, obviously, because that would require like a full week of talks. But I wanted to show you the most important ones, or at least the most interesting, in my opinion. We will be looking at the relationship between Python and Django. How does the language work with the framework in order to help it achieve its easiness of use, how fast you can develop in it, and lots of more stuff. We will be looking at these particular features of language and how they relate to the framework. So let's get started. Oh yeah, one more thing. The Django version we will be looking at is 3.1.3, just in case you want to go look at the source code later and go in depth with some of these subjects we will talk about here, so that you are looking at the same code I was looking at when I was making this talk. So we begin our journey with generators, more specifically the iterator method of the Django query set. If you haven't used the iterator method, it provides a very efficient way for accessing large amounts of data. We will look at it at the specifics in depth later on. But for now, you just need to know that when you need to work with huge amounts of data, and you might probably run out of memory doing so, using the iterator method on the query set can help you in that way. Not always, but sometimes. And under the hood, it uses generators. But in order to understand generators, we need to first understand iterators. Here is the usual for loop in Python. It's probably the most oversold feature in all of Python. Probably one of the first things anyone who works with the language learns, and the one thing that hooks them in because it's incredibly easy to use. It's very powerful. In just 2 lines, you are walking through every single member of an object, in this case B, and printing whatever it is. If you look at the how we got there, iterators are actually not an invention of Python. They actually appeared as a programming pattern, which is documented in the design patterns book, the Django 4 book. But of course, there was no Python around, or there was, but it was not as popular as it is now. So the other object-oriented languages such as Java and C++ at that time didn't have iteration as a core part of the language as Python does. So the way to work around that, as with all patterns, patterns are just a way to overcome missing features in a language. So the way they worked around that was to kind of implement their own form of the iterator iteration protocol, but it required creating lots of extra classes, lots of extra relationships that can be quite difficult to understand. I mean, if you look at this diagram, you probably, if you're not familiar with UML language and what the interfaces are and what composition is and what those arrows mean, you probably take a little while to understand it. But the idea behind iteration was there in the first place, and Python was the Python people that worked on Python were smart enough to notice that it was a core part of any programming language, and to add a mechanism in order for it to be easy to use. And the way it works, iteration is a protocol. This means that type doesn't really play a huge part in using it. If I ask you to tell me what B's type was, just by looking at this code, you wouldn't be able to do that. It could be a list, it could be a dictionary, it could be a tuple, it could be any kind of object that implements the iteration protocol. You can even define your own classes that implement the iteration protocol, and in that way, any instance of that class, um, when the for loop acts upon it, it will know what to do. How do you do that? Well, we start with iterables. Iterables are classes that implement the iteration protocol. What is the iteration protocol? Well, the iteration protocol, it's said that it's any class implements the iteration protocol when it implements the dunder iter method, which is the method that is called when you call the iter function on it. If the class doesn't implement this method, then as a fallback, then the for loop will use the getItem method, the one that is used for accessing members of any sequence, like lists or dictionaries. And if it doesn't have any one of these two methods, it will raise a type error and saying that the object is not iterable. But what is an iterable? An iterable is any object that when called the iter function on, it will return an iterator. And it's very important that you get this difference. And an iterable produces iterators. There are two different things. It might not look at it, like that at first glance, because there is under the hood, Python kind of blurs the distinction between the two, but these are two different things. An example, if we didn't have the iteration protocol, would be this one. In the left side, we iterate over the list using the for loop. Yes, it's a very straightforward way of doing it. But if we didn't have the for loop, we would have to kind of do the same thing by hand, which is getting an iterator from the nums list and then retrieving the next item from the iterator until it has no more items to return, which will make it raise a stop iteration exception. But what is this next function? This next function tells the iterator to give us the next value that it has. And when it has no more values to give us, it will raise the stop iteration exception. This is a way of signaling that the iteration is over. In fact, under the hood, that's what Python does. It just calls, every time you use the for loop, it would just call the next function on the object you pass it, and then go on until a stop iteration exception is raised. And here we can find the distinction between iterators and iterables. An iterator implements the next method, while an iterable implements the iter method. But one way to simplify it is that you can think of iterators as iterables as well. If they return themselves, then they return iterators. So they are iterables. Sorry for the tongue twister, but that's the way it is. This allows you to use an iterator where you would use an iterable without going through all the hassle of actually explicitly getting an iterator by using the iter function and so on. So we said that iterators return values one at a time. In the previous example, we used the list. But what an interesting question that comes out from this is, do we need to know every value the iterator returns in advance? And the answer is no. We don't necessarily need to know that. So how do we create these values or retrieve them as they are requested? The answer is using generators, which are iterators. The difference is that generators have the ability to suspend their execution every time they return the following value using the next function. They will effectively stop right on the point the value is returned. You can this value is returned using the yield keyword, and then give control to the object that actually used the generator. So how do we do this? Well, we implement a generator by implementing an iterable. We implement the iter method and then return the values one at a time. In this case, every time a value is yield, it will not go on until the iteration is stopped. It will actually just yield the value and go on. There is an even easier way to define generators using functions. You don't even need to define a class. Every function that has a yield statement in it will automatically be converted to a generator, which means that this generator will not really work as a regular function. In fact, when you call the function, it will return a generator. It will not execute the function to its end. And then you use the generator as you would use any iterator. You can also make generators interact with each other and get values from one generator to another. This is done by using the keyword yield from. This means get this value from this generator and pass it over as if I was the one who created it in the first place. This is a very interesting concept because from this, all the stuff about asynchronous programming and coroutines and futures and all that stuff was built on the building blocks of generators. But that's obviously a topic for another talk. So how does this relate to the iterator method? Well, the thing about the iterator method is that when you evaluate a query set, you usually retrieve all of the values from the query you perform on the database. But if you have a query that returns, let's say, thousands of hundreds of thousands of rows, to give an example, and you might run out of memory in that case, then you probably are in a kind of trouble, because you have to find a way of working with the query set a bunch of values at a time. And this is where the Iterator protocols shines. This does actually that. It queries the database one bunch of objects at a time. In some cases, most specifically when using Oracle or Postgres as database backends. And uh, the trade-off is that the performance is reduced because you're actually making very extra queries to the database. But it's a trade-off you have to go through if you want to deal with large query sets. So how does it work? This works. You define the query set. Instead of just evaluating the entire query set, you say, I will evaluate this query set in, let's say in this case, 500 rows at a time. That's the only thing. And then you work with the query set as you would in any normal case. How does Django implement this? Well, the query set class implements an iterable class, which is model iterable. And in the iterator method, it will yield from values from this iterable class, one at a time. What are these values? Well, these values are the results of this query. You will see the line compiler execute SQL, which it brings you the results, and then for every row in result cider, it will yield a single object. What does this execute method do? It calls a cursor iter function. The word cursor in database language, let's say, means a pointer to the current row the database is querying. So in this cursor iter function, it retrieves a bunch of rows at a time from the cursor. Would say, give me the, let's say we define what 500. Okay, let's say for 500, it give me the rows of this query 500 rows at a time, and then we yield these rows outside. You will see that here that the iter method receives a second argument. This is called it changes the behavior of the iter function. In this case, if the value returned by the function is equal to the sentinel value, the iteration will be stopped. Normally, that wouldn't happen if you use one single argument. So the next one I would like to see is decorators. The login required decorator in Django. What is a decorator? Well, a decorator allows you to do an extra things before, either before calling a function or after calling a function, or maybe both, in a generic way. So it doesn't depend on the function that you will call later. And again, this decorator thing is not really an idea that was born in Python. There is a corresponding pattern for it in the Django 4 book, but again, you can just see you can just look at the diagram to figure out why it's not as desirable as the Python one. The way you define a decorator is a function that generates a function that will execute one function that is passed as an argument. So if you define an inner function, you can just define the behavior that you want before that function, then call the function with the original arguments, and then return the result. But how does this work? What is the idea behind this? Well, what is a function really? It is an object, right? Well, in fact, everything in Python is an object. What are arguments of functions? If everything in Python is an object, then if function parameters are objects as well. And if a function is an object, that means that we can actually pass a function as an argument to another function. In fact, there is an example here. We just derived like the execution of the function to another function, which gives us the same result. So we can actually pass functions as arguments. And if return, by the same token, if we return values of objects, then functions can be returned from another functions. So the way this works is decorators take one function as an argument and return another function that does some stuff after or before or both calling the function that was given as a parameter. So we have this function sum function, and this yet another thing function is a decorator. The way we decorate the function is we call the decorator function with the function we want to decorate, and then assign it to the original function as to overwrite it. In this case, with the sum function is the original function with the extra behavior provided by the yet another thing decorator function. But Python provides us a baked-in way to do this using the add operator, and the add operator does the same thing as we saw before. It calls the added function, passing the second function as a parameter. In that way, it's more explicit and in the way the function is decorated. We can also have parameterized decorators. Sometimes we want to change the behavior of the decorator based on different parameters. So in this case, how do we do that? We just go one more layer up, and we add another, and we add another function, which takes the parameters of the decorator, and depending on of these parameters, the decorator will behave differently. This means that we have to decorate two things, let's say, because we have to generate different decorators depending on the value of the parameter. How do we work around it? We can just call the decorator as it was another function. So the on also do this function will be evaluated first, and the result of that will be applied the add operator as a decorator. How does the login required decorator work? Well, it does two things. It is used for checking whether in a Django view the user needs to be authenticated before actually accessing the view. So if the user isn't logged in, it will be redirected to a login page. And if it is logged in, the view will execute normally. And this has the advantage that the view can access the request user attribute, the user attribute in the request object, because the function was decorated with the login required decorator. So if it doesn't get out of that view, then it must be because the user was logged in. And the login required decorator is just a function that calls a user passes test function. We will see in a second what it does, but it basically takes a function as an argument, which is a test to apply to the user. In this case, if the user is authenticated, but it could be anything else. I mean, maybe the user first name starts with an A, to give an example. And there is an extra check after that, which is very interesting, because you can actually call the login required decorator two ways. You can either call it as a regular decorator without any parameters, or you can pass it parameters to it. In the first case, if you call it as a regular decorator, the first argument will be a function. If it is called with parameters, the function argument will be none, because you won't pass an argument by name. So in that case, it will actually return the actual decorator instead of the actual decorator applied to the function. So what does this user passes test function do? I had to remove some bits of code because it was very long, but the main idea is here. The user passes test is actually a decorator generator function, for a function that generates decorators, um, because it is a parameterized decorator. So we define a decorator that takes the view function as an argument, and then in the inner decorator which will be executed when the view is called. It will evaluate the test function we passed earlier. If it passes it, then the view is returned, is executed as normal. Otherwise, it will return a redirect to the login path it had earlier. So if the test is not passed, then the user will be taken to a login page in order to authenticate. For context managers, we will be looking at the atomic decorator for transactions. Let's say we have a view that performs a lot of mutations on a database. In this case, we have a create artist view. The first thing we do is to log a visit from the user saying that it entered the artist view. And then we get the artist data. We create an artist object in the database, but we also get some album data and some songs data. So we also create those as well. So what happens if, let's say, the song create operation fails? The album was created, the artist was created, but if we do the same request to this view, it might generate some problems with the data because the artist was already created, the album was already created. So how do we work around this? Do we really want to keep the artist and album data in the database, or do we want to erase those and then tell the user to try again? And this is where the concept of database transaction appears. If we have a set of queries and we group them inside a transaction, then the database guarantees that either all of these queries get executed, and if there is an error, then the whole group will be rolled back. So as if none of those queries ever took place, even if the error came later down the transaction. The way a transaction works from the database side is we begin the transaction, we execute a set of data manipulations. If no errors occur, then we commit the transaction to the database. This is the actual write operation on the database. If there were some errors, then we roll back the queries and end it. So how do we do this? Well, we just saw that decorators can be used to assign generic functionality to a view. So why don't we use that? It's just importing the transaction, which is the transaction module, which has the atomic. It actually is a decorator. You can use it as a decorator. So let's just do just that. We decorate the view function, and that's it, right? Well, but the problem with doing this is that the whole lot of queries inside the view will be added to the transaction. So in this case, the visit log will be erased as well if there is an error. But the user, do we want to delete this log if there was an error in the transaction? It's actually a separate query from the whole queries that were down below. So what we need here is actually a context manager, because we only want to apply this behavior to a set block of statements. And that is what a context manager is. It works the same way as a decorator, but instead of decorating, let's say, functions, it decorates code blocks. And the way it works is any context manager is an object that implements two methods. The enter method, which is executed when you enter the code block, which is indented on the with statement, and then the exit method, which is executed when you exit the code block. How does this work? Well, if we look at the atomic function, we can use it as a decorator, but we can also use it as a context manager. So if we use it as a decorator, the first argument, this is a very similar pattern to the one we saw in the login required decorator. If we use it as a decorator, then the first argument will be a function. We call the callable function on the argument, which tells us if it is a function. And if that is the case, then we return an instance of the atomic class. We will see what this is later, and we call it with the using function argument, which is the function that was decorated. Otherwise, if we call it with as a parameterized decorator or as a context manager, then it works differently. We just return an instance of the atomic class. And what is this atomic class? Well, it's a class that implements the context manager protocol. It has two methods, the enter method and the exit method. In the enter method, we see that it gets the database connection, and then the preparation for the transaction is to set the connection to auto commit. In fact, Django sets every set of queries inside a request inside a transaction, but we can manipulate that manually in order to subdivide the transactions, which is what we did in this case. And when the exit block is, and when the exit method is called, that means we exited the context manager block, which means it's time to decide whether we are going to commit the changes to the database or rollback. So we do just that. If we try to make a commit to the database, if we get a database error, then we try to make a rollback. If we also get an error, this means the connection was closed. The connection, something went wrong with the connection, so we don't need to do anything else because we can, the commit failed and the rollback failed, so nothing actually came of it. And Python provides us with an interesting way for defining context managers without having to go through all the implement a class that implements these methods. We can just use a function and decorate it with the context manager decorator. What this does is take a generator as an argument, drive it to the first yield. This will be the equivalent to the enter method. Anything we put before or yield will be the enter method. And then drive it again with the next function, which drives the behavior, the execution of the generators. And that will be equivalent to the exit method. If you know some mathematics, this function is actually, I think, I like to see it as the Euler's identity, because we are using decorators and generators and context managers all in one thing and in very few lines of code, actually. So it's quite beautiful to me, at least. How does the context manager decorator work? Well, it takes a function and it returns another function that when execute will return this generated context manager. Before moving on that, I want to point out the wraps decorator on the function that was passed as an argument. The thing with decorators is that decorators and functions, and when you execute decorated functions, you are not really executing the original function, you are executing the decorated one. So this means you lose the metadata of the original function, its signature, its return value, all of that stuff. How do you work around that? You use the functools wraps decorator in order to tell the function that will be returned from the decorator to replace all of its metadata with the original function metadata. So the interpreter, when it inspects it, it will think that it's looking at the original function. And this is helpful for debugging. If you are working with a function signature, then you need the original function's metadata and so on. So this generated context manager is a context manager. This is the actual object that converts the generator to a context manager. We need to return a context manager from this, so there is no way around it. It is implemented as a class. The enter method will try to execute the provided generator to its next point. And it will expect to find a yield in that. And what happens in the exit is we drive the generator once again, and we expect a stop iteration to happen. Because if we don't get a stop iteration, that means that we have 2 or more yields, and that's not how the generator function that works as a context manager is supposed to work. So it will raise an error. So there's lots of other stuff to go over. If you are more interested in how Python works and how its features stand out from other languages, then I can recommend these 2 books to you. The first one is Fluent Python, which is most probably the best Python book I've ever read. And then you have Python Cookbook, which kind of goes around the same things, but in a more practical way, in handling files and network connections and using the stuff that we just saw and more in order to do it in a more Pythonic way. So my conclusion, I guess, from all of this is Django is the best thing ever. If you used it, you will know that it is really well, maybe not the best, but one of the best frameworks around. It is very easy to use. It is very fast to develop in. Python obviously is the best thing ever. If it wasn't, then we wouldn't probably be here in this conference. And a question I would like to ask is, what would a Pythonless Django look like? Would we still get the same result if we used a language that didn't have iteration baked in, that didn't have decorators, that didn't have context managers, and many other things? Would we still arrive at the same framework? How much of the genius of Django is because of the genius of Python? So that was the talk. I hope you enjoyed it. And if you have any questions, my future me is going to answer those. This is actually a pre-recorded talk, so I hope you didn't notice. You probably noticed, but who knows? So thank you and goodbye.
Thank you for your presentation. It was really interesting.
Thank you.
So then they're finished, and you can connect to the next presentation.
Okay.
Thank you.
Thank
Goodbye.
you. Goodbye.